Okay, so we've got the expression 4x cubed plus 10x squared minus x plus 15, and we know it's got this factor of x plus 3 over here. So if we think about it, if we wanted to factorize this, we know it's going to be in the form x plus 3, and then we're going to get something of the likes of, let's say, ax squared plus bx plus c. And the reason we know this is, we know that that's third order, so if we take out a linear term, sorry, a linear product, we're going to get a second order expression over here. Do we agree? So, if we know this, then what we can do is, rather than dividing the answer out, we can multiply the answer out and then deductively figure out what a, b, and c are. So, do we have a way in which we can expand these brackets efficiently?
Yeah.
What method do we employ?
Synthetic multiplication.
Yeah, we just go synthetic multiplication. So we can expand this out quite quickly using this technique. So 3c's are 3c, 3b's are 3b, 3a's are 3a. Put in a gap. 1c's are c, 1b's are b, and 1a's are a. Next, sum them. 3c, 3b plus c. I'm using brackets on these so I don't get the expressions mixed up. 3a plus b. And then we got a on the left there. So when we expand this out, what we discover is we have 4x cubed plus 10x squared minus x plus 15 has to equal 0, 1, 2, 3 ax cubed plus 3a plus b x squared plus 3b plus c x plus 3c. So now we've got one equation. Here's the part where we use matchy-matchy or inspection, depending on what you want to call it. What we're going to do is we've got three unknowns, so we're going to build at least three equations to solve this. Now looking at the first one, the coefficient in front of the cubed term is 4, and over here it's a. So what does this tell us?
A is 4.
A is 4, so that's your first clue. What about the squared term?
10.
So we know that 10 is going to be 3a plus b. But what do we know about a?
4.
So b in this case is going to be minus 2. So that's your second clue. Third clue. What do we know about the linear term here?
Just -1
Equals 3b plus c. But b was found to be minus 2. So if we sub that in, that's going to be minus 6, so c will be 5. And here, this guy over here, we've got all our values for a, b, c, but we're able to make 4 different equations, not 3. 3 unknowns, but 4 equations. In some respects, we don't have to do this, but there's going to be situations where we do. And the reason for that is 15 equals 3c, but c equals 5. 15 indeed equals 15. So what do you think this line over here tells us? tells us that, I shouldn't write that in math. Tells us that the solutions we got must be true. So therefore, the factorized form is going to be x plus 3 multiplied by ax squared, which is going to be 4x squared plus, which is minus 2x, plus c, which is going to be 5. There's your semi-factorized form into the quadratic. And then using our roots that we discovered previously using the synthetic method, what do we end up getting?
1 plus minus root 19 by
1 plus root 19 with an I in there, all over 4 times x, take 1 minus I root 19 all over 4. So there's your factorized form there. So the method we employ in this case is synthetic multiplication, just to make this go quicker. Then we do equate to go by inspection. Then you just go simultaneous. So this is the, I believe it's a fourth method that you're adding to your toolbox on how to find roots, or how to, in this case, fully factorize. All cool?